And in fact, you actually look at the biblical dimensions of it in cubits, you find out that boat would have been 1.5 to almost 2 football fields in length. And so all of a sudden, we're looking at a great big boat, aren't we? Nothing small. And no problem getting all the animals that had to fit on board that boat, okay? And in fact, I even asked him how many animals had to go on board that boat. He said, I didn't check into that. Certainly they couldn't fit. I said, could you tell me how big the boat was? He said, well, I don't know that either, but I'm sure they didn't fit. And basically my answer is, what you're trying to say is an unknown number of animals can't fit on board a boat of unknown size. And anyhow, so basically, you know, when you look at the flood, the biblical record for specifically, the flood is one of the most documented events in the Bible. Yeah, there's several chapters, and then later, not only do you have in the Old Testament, but you have it in the New Testament too. The New Testament authors also accepted the flood as a reality, and even Jesus himself accepted the flood as a reality, okay? And so if it's good enough for him, it's good enough for me. All right, now, is there evidence worldwide for a flood if it's a worldwide flood? Well, there's much archaeological evidence, number one, and you look at some of the clay tablets and some of the other things, and you realize you're talking about the same flood. You've got the Sumerian kings list, names kings who reigned for long periods of time, and then a flood time, and then a great flood came, all right? And then after that, according to the tablets, the Sumerian kings ruled for much shorter periods of time. That fits exactly what we know from even the biblical record and other cultures around the world that talk about people living long ages compared to what they're living today. And when you look at that, you find out there's a thing called the flood, where right at that red arrow, notice that the length of years that people lived were a lot higher before that flood and then until after that flood. I wonder what's going on there. Something must have occurred at the time of the flood to possibly change the climate or some conditions that people could not live as long. And you say, what about the one on the left there? It didn't look like that guy lived very long. Well, that is Enoch. He did not die according to the biblical record, okay? God took him directly. So that's Enoch. So we also have the Babylonian clay cuneiform tablets. And some people said, wow, it looks like the biblical account. Maybe the Bible was borrowed from this, right? Well, actually, their problem, they had an ark that was shaped just like a tin can. And I wouldn't want to roll around in that thing for a year in the flood waters, I can tell you that much. Then we've got the Babylonian documents, the same flood, several documents, one of which you can look at is called Gilgamesh Epic, 11th tablet. It had an ark, it had animals taken on board that ark. Not only that, birds were sent out during the flood, and the ark landed on a mountain. Then there was a sacrifice offered. It kind of sounds a lot like the biblical record, right? And so people say, well, maybe the Bible was borrowed from the Gilgamesh epic. Well, one problem is the Gilgamesh ark is shaped like a cube. And I wouldn't want to float around in that as I turn every which direction. And then you wonder about it. They believed the Gilgamesh epic was the most ancient of those texts. But the problem is, I don't think so. Because when you look at the biblical record, starting with Genesis, it wasn't the fact that Moses is the one that we should date it all at, but when you read Genesis chapter 1, it says there These are the generations of, and it gives a patriarch. These are the generations, say, of Adam. These are the generations of another patriarch, 6 or 7 different times. And what that means, the generations of, according to Dr. Henry Morris, could easily mean these are the records that were kept by this patriarch, okay? Which means those records were a lot older, okay? A lot older. Well, do you know there are over 270 flood legends from around various parts of the world? And then not only that, you know, they have a boat, they have animals, they have people being saved, but that was all over the world. But just in the Americas alone, there's been a recent book called Echoes of Ararat, and there they have actually documented 300 flood legends just in the Americas alone. Okay? But there's a common thread through all of those that fit with the biblical narrative. So somehow or another, something happened that this message got spread all over. And we think it's after the flood and the dispersion of the people after an incident called the Babel, okay? Tower of Babel. Okay, now, not only that, ancient Chinese language reflects the biblical record as well. Like their word for boat happens to be made up of smaller pictures. 8 mouths in a vessel. 8 people survived Noah's flood, exactly. Now, is that coincidental? This book says it's not. In fact, it takes so many of the biblical themes in Genesis and shows the characters that go right along with that. For instance, words that surround the temptation, tempter, etc. Those pictures are woman, garden, and snake. It goes right along with that. And that would be a wonderful book. I have people that I've met from China. They said, yeah, it's 100% right on. Okay?
I have a copy of that for reference if anyone wants to look at the end.
Yeah. Mm-hmm. Yeah, you do have that. There's a paper that we can pick up right there, right?
I have that book over here, yeah.
Oh, it's already over there.
Yeah, it's in the box underneath the table.
Well, if people want to look at that, you're welcome to do so, okay? All right. The one thing about Noah's account, as given in Genesis 6 through 8, is its specific details. I don't call it a story. Some people call Noah's flood a myth or a fairy tale. Well, how do myths start? Once upon a time in a far distant land, right? No, look at the detail. In the 600th year of Noah's life, in the 2nd month, on the 17th day of the month, on the same day, all the fountains of the great deep burst open, and the floodgates of the sky were opened. That's specific detail, exact day, what we're talking about here. He is writing this down. All right, now, it's interesting as well, we find 2 different sources of water, it looks like. Fountains of the great deep, water coming from below, water coming from above. And it doesn't stop there with that detail. Every major event during the flood was documented. What year, what month, and what day it was. And you look at the bottom, and you find out the 2nd year, 2nd month, on the 27th, the earth dried, and Noah was instructed to leave the ark at that particular point. So how long was Noah on that boat? Over a year, okay? This is no local flood, all right? This is something major that was going on. Not just a little rain either. The biblical record is very catastrophic when it talks about it. It says the windows of heaven were opened. And then it says the fountains of the great deep opened up. And why was it I say it would be a worldwide flood, not a local one, in other ways, besides those texts right there? Well, why do you need a big boat for a local flood? Flood comes, it goes, bam, it's all gone. Don't worry about it. Uh, okay, why take birds on the ark if it's going to be some local event? And according to the biblical record, the water covers the tops of the tallest mountains. Think about it. If I cover Long's Peak in Colorado, what does that do to you here in Minnesota? You know, as Bill Cosby used to say, how long can you tread water? Anyhow, it was definitely, it covered the tallest mountains. And, well, even Everest, that's the tallest mountain in the world, right? Yeah, the tallest mountains. Now, we will not say that the mountains were as tall prior to the flood as they are now. I don't know that that is true. We do see evidence of the tops of all those big, tall mountains having sedimentary rock layers which contain fossils of creatures that swam in the ocean. But all that shows us, at least, not proof for a flood, circumstantial, but it shows that mountain was under water at one time, right? And those layers were put down under that water. Okay, so here's where some skeptics have a heyday with that. Oh, now we know that that is nothing but a myth. We don't have enough water on planet Earth to cover the tops of the tallest mountains. Okay, number one, there is an answer. Number one is the mountains weren't as tall as they are today. Everest is still rising, by the way. And if you want to go climbing on that, Parnell, you better do it tomorrow because you won't get any other chance. It's getting bigger.
I got little kids. I can't do that.
Yeah, okay. And there's another answer given in Psalm 104. Psalm 104, in one verse, it says, the mountains rose up and the valleys sank down. And it appears like it's right at the tail end of the flood. So the mountains are taller today. Now, do we have enough water? Let's take the whole world and flatten out the mountains with a giant iron, and let's fill in the trenches like Mariana's Trench that's, 7 miles deep? It's a deep one. And make the whole world kind of look like a soccer ball. How much water would we have then that would cover the earth? Well, just with that amount of water, we could cover the earth to a depth of at least 1.5 miles deep of water with the present amount. Plenty of water to get the job done, right? And by the way, they now realize from geophysical studies that underneath our continent, down into the mantle, there's a certain type of mineral called dimwoody. That's what it's called. And they say this is a mineral that sweats. It sweats. There's a lot of water in it. How much water, they're saying? Well, if you just look under North America continent, that particular amount underneath our continent has 3 times the amount of water in it than what's in the entire oceans around the world. 3 times. That's just under North America continent. I didn't even take into consideration the other continents either. Well, another reason I mentioned already, the duration of the flood, over a year. Now, they had a nice flood up here in Duluth, up north, right? That was in June. And boy, there was a lot of flooding up on the North Shore. And you know what? You go there today, you won't even see anything. After 2 weeks, it was already gone, okay? That's all it took. And so, anyhow, so plenty of water. That wouldn't be an issue at all. Yeah, good evening.
Good evening.
See it.
All right, so anyhow, and if you look at a biblical passage here where God sent the rainbow as a promise, he wasn't going to flood the earth again. All right, we've had so many local floods. This was one big flood. He's not going to send that type of a flood. All right, And we also notice there's much geologic evidence worldwide for that flood. Okay? And it all depends what kind of lens that you're going to look through. Okay? And that makes a big difference. What are your assumptions? What kind of glasses are you going to look at through? If I look at a white wall through red glasses, it'll look red. If I look at the wall through green glasses, it's green. If I look through glasses that says millions of years of evolution, that's all I'm going to see normally, right?
Yep.
I have no other choice. If that's all I've ever been taught, that's the only pair of glasses I own. So, So people ask me all the time, well, what about continental drift? Okay, that proves the Earth is millions of years old, right? Does it really? Okay. Well, let's think about it for a minute. We do realize that things are drifting according to the standard science today. Even the Atlantic Ocean is widening right now. Okay? That was a 2021 publication there. Now, let's just think. That's based upon the assumption that this has been moving at the same rate very slowly over all of those millions of years. Correct?
Yep.
You don't know that. That's an assumption, right? And you might be able to try to support that with certain fossils, geologic things. Doesn't work all the time, not as nice and neatly as we've been told it is. What if the continents were spreading faster? And it's not very fast. How far? If you would take 5 inches per hour, that's not moving very fast, is it? Right? Oh, it's barely moving. But even at that rate, 5 inches per hour, it would take only 4,500 years to get to the present positions.
Wow.
All right? 4,500 years, that's all it would take for the 3,150 miles. Okay? All right, well, we do know one thing about the study with the Atlantic is widening is they underscored something I've been teaching for a number of years. And that's this. If it is widening, that means you've got new volcanic material, new rocks forming at that spreading center. New rock is a whole lot less dense than the old rock. We know that. That's a geologic principle that works with the seafloor. Okay? That's what we do know. Anyhow, but we know it's lighter. If it's lighter, mantle's going to push up a little bit, right? With the mantle pushing up on it, that's going to cause a little bit more spreading. Okay? But here's something that's extremely important. If it is lighter and it's happening at a little bit better, a higher rate, what's going to happen is it's not only new seafloor that's being formed that's lighter, mantle's pushing it up, and when it does, you know what else is pushing up? Ocean levels. Ocean levels would come up. Dr. John Baumgartner, who was interviewed in Time magazine a number of years ago, I have the privilege of spending hours with him, okay? Amazing geophysicist. He was interviewed with Time magazine. They called him the top geophysicist in the world. All right, then they found out he was a creationist, and he almost lost his job at Los Alamos Labs, okay? But he's he goes all over the world with in analyzing things for them. But Dr. John Baumgartner began working on a computer-generated model that was called the runaway subduction model. And did I say something about the what if the continents were moving a little faster? Well, if we're moving a little faster, what does that mean? That means the subduction is going faster. It's going faster. Now that's very important because if you increase the speed just a little bit, it also increases the temperature where it's going in the mantle because of frictional forces. You may not seem like that'd be a lot, but it really is significant. And so what happens is now that temperature where it's going underneath and into the mantle increases. When the temperature increases, that's going to become more fluid. That means the oceanic crust is going to even go faster, generating more heat, more fluidity, faster, faster. And like a conveyor belt, that entire seafloor can be subducted underneath the continental masses, all the way down into the mantle. Circulating around then. When you get the circulation, that'll produce magnetic fields, by the way. And all of his model is really touches on so many points, and they're all valid. So this is called catastrophic tectonics. But notice this thing right over, I don't know if you can see that arrow or not. No, just on my computer. Okay. There. Look at that middle. What?
I was seeing your mouse arrow.
Oh, you did. Okay.
I did see it there. You were.
Right there.
No, I don't know.
How about where that red arrow is, where it says rising magma? You see that right on the left-hand side, right at the Mid-Atlantic Spreading Ridge? Mm-hmm. You see that. Good. Okay. Now, that means that magma is coming up. And that's going to fill in the crack as this seafloor is spreading. Well, that crack is going to be new seafloor material. It is not nearly as dense. Okay? That means the mantle is still pushing up on it. What's going to happen? The whole level of the sea is going to rise. How much? According to his model, at least 7,000 feet.
Oh, my.
In that, 7,000 feet. Well, what is that going to do to Minnesota? How long can you tread water? Okay, that's what it would do. And so this particular catastrophic plate tectonics answers so many things in geology. Okay. If it just increases a little bit in speed, okay, now you're going to have a rising seafloor. If it goes down in speed, now you've got a lowering sea level, right? And that can explain the specifics of the what are called the rock deposits, gradient of sediments, where you go from larger rocks to smaller rocks but this reverse gradient is what they're always were, reverse gradient bedding. And basically what you have, they've had a hard time explaining all that, okay? Very hard time. And geologists are jumping on this model saying, this is a great model. But the problem is once you get that started with a little extra heat, you can't stop it until the whole subduction is completed. And by the way, you do the mathematics of it, about 1 year. About a year of catastrophic activity, and that whole thing is subducted. That's John Baumgartner, and that's his model. You can read that, and if you want that, you see the May, June 2013 is when I first wrote that article relating to his research. Okay, there it is. It's on our Think and Believe on our website. All right, so when we look at also at rock layers as well, we think lots of time or lots of water. What works better here? Okay, now let's go to Southern California. We're going to look at some things in Southern California. You see, this is called Split Mountain, and the earthquake cracked the mountain open, And it showed us what was made up inside that mountain. And what is it? Water-worn boulders, some of which are the size of that dump truck. Hold on, that tells you you're looking at very high velocity and very deep water to move that kind of material. In another spot, you look at layer after layer after layer of these boulders. Some of those are the size of the Jeep. Again, high velocity current that is very deep. Right, Gary? Is that what it would be?
Jerry?
Oh.
Oh.
You talking to me?
Yeah.
Sorry.
Wouldn't that take a lot of high velocity and deep currents?
Very high and
Yeah.
very deep.
Yeah, right, okay. Again, how about this one? Where you have the same type of boulder material wedging its way into the layers on our right like a fist into a layer cake. Now, according to standard geology, the layers on the right were 100 million years in the making. But hold on, the way it bent down this way and that way shows you that those layers were still soft when that happened. Now, it only takes a few hundreds of years, probably, to turn that type of sandstone into rock. It's like pouring concrete almost, okay? So the arrival of that tells us, forget that 100 million years right there. And again, it's a boulder flow. We don't see anything like that happening like that today, do we? Not of that magnitude, okay? Not of that magnitude. We do see smaller things after Mount St. Helens erupted. Now, Mount St. Helens was a wonderful volcano. Why? It's a living laboratory, okay? And it was a gorgeous spot to go visit, you know. You can go sail on the lake and all that kind of stuff. And, but then the mountain took up a bad habit. It began to smoke. Not good when mountains smoke, let alone people, you know. Then they noticed one other thing. The mountain was beginning to bulge. This mountain was bulging between 18 to 40 feet per day. Now, if you live near the base of that mountain and it's bulging toward you, what should you do? Run! Get out of there, right? And sure enough, as geologists were predicting, this is going to blow. It's just a matter of time. May 18th, 1980 was the day, okay? And that began to erupt, blew out the side, and then went straight up as well. And we lost a lot of mountain that particular time, but we gained a lot of knowledge on canyon formation, layer formation, etc. How that can happen in such a short period of time. These are layers, and they're fine layers, and what formed those? Well, we noted what happened. You know, when you get all that volcanic ash up there, it is hot, okay? What goes up must come down, okay? And it came down like this, big sheet flows. In geology, it's called pyro, which is fire, clastic particles, okay? Pyroclastic flows, blanketed the countryside, in other words. Wow. And we found out when they hardened, which is just like that, we would look at something, we'd say must have taken billions of years to form. But it happened in one day, okay? That's all it took. All right, I've been at Badlands when they tell you that the layers that were formed there took millions of years to form. You might say, sir, didn't we see the same thing happen at Mount St. Helens in one day? And you know what they would say? Well, Mount St. Helens was a special case. Maybe this was, okay? Maybe, huh? And they say also, you can't get that kind of erosional pattern in a day. That's going to take millions of years to form. That isn't exactly right, because at Mount St. Helens, our living laboratory, you might say, we had secondary steam blasts that produced steam pits. This was a quarter of a mile across the narrow part. Okay? Same Badland topography. So you see, it doesn't take millions of years to produce that, right? And it doesn't take millions of years to make canyons. In fact, that canyon goes for 22 miles back there. And it's not on the map prior to 1980. Okay? So how long did this one take? The eyewitness report, the video clips, etc., showed this canyon was carved one day. One day. National Geographic picked up on it too, and they even said, you would expect a hard rock canyon to be even hundreds of thousands of years old, says Peter Frenzen, monument scientist. But this was cut in less than a decade. Keep in mind, it's hard rock, and it is less than a decade. Most of it is one day, okay? It's the conditions that are more important than time. Now, think about the amount of water that would have been involved with Noah's flood if it was a worldwide event, not just one or two glaciers suddenly melting, bringing all that water mixed with the ash, now mixed with boulders. We saw it on videotape. That flow, called a Lahar flow, that's what it was called. It turns out that particular flow, there were oil tanker trucks floating on top of this stuff. You understand the density. And it's, in this spot, it was going right here, going through that canyon, it was going at 35 miles per hour. Downstream, took out some bridges, of course, right? And think about the huge waves, the amount of water with no wake flood. Nothing, it's worldwide, nothing to stop the currents. We're gonna get a whole facelift on planet Earth is what we would do, okay? And so anyhow, here's a principle of geology for you. Okay, this is petrified wood or mud at Bryce Canyon National Park. All right, I love taking students there because it's so much fun. All right, great hiking. And interesting, petrified mud, that's all it is. Here's the principle. When you see petrified mud, think flood. Simple?
Yep.
Very easy. You'll be right a good share of the time. Well, here's some petrified sand mud. Think flood, okay? This happens to be right pretty close to where I live, okay? Yeah, but they say sandstone formed by wind-blown sands. Not always. You have water-deposited sand dunes too. A lot of people don't know it. And you can check on the distribution of the cross angles to figure out if it was water or wind. And those big ones we have around the world, water deposited, okay? Anyhow, Colorado National Monument again. I live right at the base of that whole thing. I get to look up into it from my house. Great view. And, but they say it took millions of years to make canyons like that. No, what if we had more water? Remember, we're gonna change lenses here. One lens, ancient, one other might be the younger version. More water. Well, there's evidence for more water. This is a canyon within a canyon. Do you notice the little V in the center of that? There was a lot more water, carving out most of it, water channelized, carving that inner gorge. Okay? Again, evidence of more water. And by the way, the mountain in the background is Grand Mesa, Parnell. That's where I love to fish.
Ah, there you go.
Okay, it's a great spot up there. Okay, anyhow. Glen Canyon Dam gave us a great example of what a lot of water in a short period of time will do, okay? There's a overflow tubes at Glen Canyon Dam. These particular overflow tubes are to keep it from water topping over the dam. Well, we had a major flood, I think it was in 1983. All the rivers in Colorado and Utah was discharging huge amounts of water. And they looked like it was going to overtop the dam. So they opened up 2 of their overflow tubes. And they were transporting out of that 40,000 cubic feet of water per minute out of those overflow tubes. Okay? All of a sudden, they notice one of them turning sandstone color instead of clear water. Oh, they said this. They said, oh, this is now cutting through, has already cut through the concrete, 3 feet, that's reinforced with iron, with rebar. And it's already cut through that, and now it's into the sandstone. And they saw blocks of sandstone being thrown out the backside of the dam. And this is evidently working its way to the face of the dam. Well, that would be a wild ride down the Grand Canyon, okay? Because this is upriver from that. Lake Powell is where that is, the Glen Canyon Dam. So they shut down that tube. Fortunately, the other one held, plus a plywood temporary part of the dam, okay? That's what they put up there. It's amazing. Engineers just shook their heads. This thing gonna work, but it did. Okay. Anyhow, all right. Let's go to Eastern Washington. That particular area is called Dry Falls. That means dry waterfall. And you look across it. It goes. That's a flat area. And you say, "What do you mean waterfall? This is flatter than a pancake out there, right?" But according to standard geology today, that particular one was what? The waterfall due to the collapse of the ancient Lake Missoula, okay? And all that water then went downstream. Now this is the M for Missoula, but notice the shorelines. That's what clued them off, that this might be the source of the water for this huge catastrophic flow that they were seeing down here at Dry Falls, hundreds of miles away. Okay? Now, here's the model that they came up with, which I think is pretty accurate. They figured that the scientists working on glaciologists there said there was a tongue of the ice dam, or ice from the Ice Age, that blocked the Columbia River, and when it did, all that water backed up. And then over at Missoula, that would have been about 900 feet deep right there. At the dam, which is downstream, further downstream, the depth of water would have been 2,000 feet. That's a lot of water in a lake, especially if you're downstream and it breaks. Okay? All right, so all of a sudden, they now realize that dam broke, and when it did, the whole Lake Missoula drain took with it glacial Lake Columbia, and all of that water went downstream, ended up in the Pacific Ocean. Okay? That's where it did. Now, I can't even draw a picture of it that would show you what's going on here. Because it's not just water, by the way. Just as soon as it breaks, it's now water mixed with dirt, sand, boulders, automobiles, well, maybe not that, but cows, whatever is in its path, right? And now it is going down, and some of the boulders are the size of houses with this amount of water flow. And now what are we seeing? All that water going downstream, carving out great big canyons like this one right here, Missoula Dry Falls. Notice the scouring above that. This is just one of the channels of this Missoula flood. There are hundreds of those channels. And they thought it might have been, oh, it's from glaciation. Nope, it turned out the water, okay? Huge amount of water. And look at that canyon downstream there. You see that? That goes for 22 miles downstream, and this entire canyon was formed within 24 to 48, get this, don't lose it, hours. Woo, amazing. It is 6 miles wide, 900 feet deep, and 22 miles long. And okay, let's look at another channel. This is at Palouse Falls. And it's a 180-foot waterfall. So that's pretty good size, right? 180 feet, a lot of water going over that. But when you look at the plunge pool below, it tells you there was a lot more water going down at one time. The lake down below. And how much water? You see those hills on the in the distance? Those are all rounded by water that was flowing over the tops of them at one time. Okay, that's how much water was going there way back when. Now, we get a little bit of water. Well, it's still a lot. And if you want to know more about that, how would you like to kayak it? There are people that kayak waterfalls, you know. 180 feet, somebody did it, videotaped the whole thing. He broke one paddle. Now, Palouse Falls kayak, and you can see it. Not right now, though. Okay, all right. Here it is, the canyon below this particular falls. Again, it's 1,300 feet deep, right there. That was probably not there prior to this flood, called the Missoula flood. Okay, same flood, scattered boulders all over. In fact, you look at that big boulder there about the size of a house, that's solid volcanic basalt, okay? And that's a big one. But a lot of people miss what you're standing on all around that field, the whole area. It's boulders. And if you drill down in the middle of it, you're going to find boulders for 300 feet deep. Okay? Yeah, this is now standard geology. They know that this is what happened. Now, boulders mean think flood. Okay? Think flood. All right, so what did I think when I saw these boulders near Escalante, Utah? Flood. But it's interesting because when I look at where they're at, there's a canyon on this side, a canyon on that side. And this is the ridge in between. So the water that was carving this out was over the top of all of it. Okay? All right, now let's go to some other boulders. Twin Falls, Idaho. It looks like a potato field, like Idaho is famous for, right? But these boulders are the size of that Suburban. Okay, there's one great big one right there. It's just all over, strewn all over. And they thought, well, what formed this? How did this happen? It looks like a lot of water was rushed through here. Where did it come from? Well, then they started associating those boulders with the shoreline near Salt Lake City, Utah. Look at that level of the shoreline right up right up here. Okay, right there. You can actually trace that shoreline for 350 miles. That means that lake would have been 1/3 the size of Utah. And not only that, it would be about 3 times the total surface area of all the lakes you have here in Minnesota. Okay? That's the surface area of this thing. That's a lot of water, isn't it? Okay, so that's now called the Ancient Lake Bonneville Flood. Okay, that's what it's called. And see that big canyon downstream? According to standard geology, according to the signposts even there now, that canyon was not there 30 days before the collapse of Lake Bonneville. And it probably wasn't there 2 days before, okay? Very likely. And where were those boulders? Up on top, okay? That's where it was, at Twin Falls, Idaho. Okay, Dury was a geomorphologist studying the geologic formations around the world and the landforms. He said, looking at the rivers and streams and the stream beds and the canyons, 95% of all of those waterways the canyon cannot be explained by the present water flow. It takes a much more catastrophic flow in order to do it. Another one of those great big lakes broke up in Siberia. And they said it was 10 times the size of the Missoula flood. Do you understand how big that was? It made great big canyons. Not only that, ripple marks, ridges left as ripple marks. Okay? Wow. Wave Rock in Australia, bone dry today, goes for 7 miles. You can just imagine the amount of water going over there at one time. Okay? So the point is, time, in this case, what we're looking at is not the hero of the plot. Conditions, lots of water, are more important. And that also have everything I showed you there were catastrophic flows, weren't they? Lots of water and catastrophe. You know, Charles Darwin sailed along the coast of South America. Went to the Galapagos Islands, of course, right? And he saw lots of volcanic layers. And he said, oh, it must have taken eons of time to form those layers. What did we find out at Mount St. Helens? One day. One day. That's all it took. And he said he took a boat up the Santa Cruz River in Argentina as well. And when he took the boat up that, he said it must have taken eons of time for that little bit of water to carve through that whole volcanic dark-colored bluff that you see over there. You know, he missed a few things. He never had his eyes tuned to what people do when they drive with me. Because when I look there, I say, boulders! They're not only boulders there, but they're boulders on top that bluff. That means there was a huge blast of water that went through there, and they now realize there was an ancient lake above that area that collapsed, forming this area. That's the Santa Cruz River in Argentina. So what do I see? I see flood. I look at these big canyons, right? I see flood. I look at canyon within a canyon. There's a flood. I'll go over to the Canyonlands National Park over some of the overviews. It is 18 miles from where I'm standing, taking this picture, over to those other bluffs on the other side. 18 miles. What does that tell you about the amount of water? Lots of water, right? Just, whoa. And there is a way to explain that with a lot of water too. Collapse of huge inland seas upriver, okay? And so I see the flood written all over that, okay? And of course, the standard interpretation you might get at the canyon is it took millions of years of gradual erosion. Their hero of the plot is time. This is their special showcase of time, and they will tell you that, okay? And no, not necessarily. I look at it and say, what if there's a huge lake upriver? And there's evidence for the shorelines of those lakes in different places. Okay, whoa, if there's shorelines, where did the lake go? The canyon might be the clue, okay? The big boulders that I first showed you, one of which was the size of a dump truck, that's right downriver from the Grand Canyon. Our clue is lots of water, catastrophic processes. And maybe the whole canyon could have been carved, or a good share of it, within weeks, maybe days. Okay? Doesn't take long. Once you break through a dam, it doesn't do it slowly. It just washes it all out. Boom! And then wash out downstream. Okay? Okay, here's another canyon. How long does it take to form a canyon like that? Well, I had an idea a number of years ago. What if the Black Canyon of the Gunnison was not carved by that little river down below? What if there was a huge earthquake? I want you to time how long it takes. Time it real carefully. If there's a huge earthquake, and here's you got this level place like this, and all of a sudden a big earthquake. I mean, we're talking about a 8 or 9 magnitude earthquake. All of a sudden, whoosh. Did you time that? You see, it didn't take long to form. with an earthquake like that. Now all you do is wash it out. And there used to be the channel for the Gunnison River. We have geologic evidence all over. It shows that channel went for miles and miles in a big circle around that whole region. Now it takes a shortcut right through it. Okay, and that's right near Delta, Colorado. And all right, I've been at Sierra Nevadas, and looking at one spot, I looked out at Sierra Nevadas and I looked across, and I said, you know, that looks like a water channel there. See the lighter colored stuff? That looks like an island, a water channel. And I thought, was there a lot of water going through here? So guess what? I climbed down. I climbed down there to see what it looked like, and what did I find? All sculpted, solid volcanic basalt, indicating a lot of water had to do that. Well, where's all that water gonna stop? The lower parts in the earth, right? Arizona. How about Death Valley? Here's one right here. Now, remember, it's not just water. It is cement flowing sometimes 65 miles per hour at you, carrying big boulders and cows, like I said, right? Watch out. And here's one right there. There's one of the dumps right there. There's Mary Jo. And you can see the boulders making this up. This is at Mosaic Canyon, by the way. Notice how the cement not only carved that canyon, but coated the canyon with the cement. You see that? All right. And you look down the little canyon there and you see the cement coating it. Look below, what do you see? The cement dump. Okay? That's what's going to happen. All right? And so what do we see? We see evidence of massive, catastrophic flooding. Doesn't have to be during the Noah's flood. It could be an aftermath of the flood. Just small aftermath. Can you imagine the erosion that the flood itself was doing? And putting down huge layers. And so we're looking at the layers forming pretty rapidly too. And then here's where the ranger at the canyon objects. No, we have radioactive decay dating methods, and it shows that those layers are millions of years old. When that was said to me, I said, sir, are you aware that there isn't a single layer that you're looking at there that can be dated by radioactive decay dating methods? Because those layers contain the wrong kind of rock. The only ones that can be dated are those way down below, okay? That's in the inner gorge. And he was a geologist himself. He said, oh yeah, you're right, I forgot about that. Okay, I can understand that. So are these dating methods really any good? We're just going to talk about these ancient age dating methods for a little bit, okay? Not carbon 14, like we were talking last night, that they dated the dinosaur bones, remember? And the coal layers and also the diamonds, all dated at thousands of years, not millions of years, okay? That was carbon 14 dating on things they would never have even considered dating with radiocarbon dating. But these are the uranium lead type dating, potassium argon, etc. Well, are they accurate? The only way to know is to date a rock of known age and see if you get a good number. They did that. Mount St. Helens had a secondary volcanic cone begin to form. When it was cooled, they took a date. Instead of 30 years, they got 340,000 years minimum and up to 2.8 million years. I say something's wrong with the method, okay? Same thing in New Zealand, same sort of thing. How about in Hawaii? They saw when that occurred. When it actually cooled, they got dates of 3 million to 1 billion years. And people said, well, maybe that's dating the mantle's material, the actual volcano stuff, the lava before it hardened. Maybe, except for one thing. These dating of the rock starts when the rock cools. Otherwise, it's so liquidy and it's like water. It's so hot, it's like water, okay? And the different particles, what's called the parent and the daughter particles, don't stay together. Only when it's cooled will the disintegration part, the parent rock and the daughter, will they remain the same. And now you can date them, okay? And so this is when it cooled. But look how far off they are on something that just happened. I say something's wrong. And there's a volcanic lava flow that actually occurred on the top of the Grand Canyon. On Vulcan's throne, it actually flowed down into the canyon one time, even blocked the river for a little while, and they dated that recent volcanic lava flow. They didn't use just one dating method. They used a bunch of them. Okay, so they decided, let's look and see if these dating methods are giving accurate results, instead of just assuming they are. And it turns out that when they dated that particular lava flow, they ended up with dates at least as old and up to twice as old as the rock layers underneath the entire canyon. I mentioned that to the ranger. He said, no way, your data's got to be wrong. I said, well, here it is. Why don't you do your own research on it? And then I told him, I'll be back. The next year I was back. I saw the same ranger. He's giving the same ranger talk. I asked him the same questions, and he said, oh, you again. Okay. Then he said, I found out you're 100% right. But there's a good answer. He said, it has been shown that these methods are not accurate on recent events. I think I told you guys that yesterday, didn't I? Okay. So the question is, think about that cartoon. If rocks of known age don't give you good results, how do you rely on the same methods to give you correct results on rocks of unknown age? It's a real problem there. Keep in mind, I see flood all over those layers, by the way. I really do. If there was a flood, wouldn't you find mass burials around the world too? We do. Here's a mass burial of clams, all unopened. Now, when a clam dies, the shell's open. Okay, this tells me they were buried deeply enough, they couldn't escape. Okay? Catastrophic burial. All kinds of different clams and shells like that, all whole, mass burial. All right, here's another one. Right there in the Grand Canyon, you find these nautiloid fossils, kind of long cigar-shaped fossils, but some of these cigars are 3 feet long, okay? They're big fossils. Some of them are 3 inches, all pointed the same direction. What does that tell you? They're being washed together by current. It wasn't a calm, placid sea where these things just rain down slowly. It was a current, a major current that was going on there. It's a mass burial of these nautilides. They have millions of them down there. And if you want to read about it, get it in that book right there, or go on our website. Okay, nautilides, we talk about them. Mass burial in Wyoming of fossilized fish. There are 360 fish on that one slab, all perfectly preserved, not a fin out of place. Little fish, bigger fish. Here's a palm frond, perfectly preserved with fish, no deterioration. What does it tell you? It's buried rapidly, no decay. How rapid? This guy is eating his lunch, and both of them got trapped. Mass burial. Okay, again, Dinosaur National Park. Look at that. All those dinosaur bones. Mass burial. 92 dinosaurs ripped apart. Now, it takes quite a current to rip apart a 70-ton dinosaur, wouldn't you think? That's what happened there. Okay, how long does it take to make oil, by the way? not millions of years. There's one report in the Department of Energy, Pacific Northwest National Lab. They were able to make crude oil in 1 hour. Doesn't take long, okay? All right, now, I'm a geologist, but when I look at rock layers, not only do I get excited, I get hungry. I think of rock layers like pancakes, right? And some of those pancakes, what's your favorite kind of pancake?
Blueberry.
Blueberry, I love them too. I like blueberry pancakes, and I love them with pecans in there too. And I think about these stacks of pancakes with syrup over the top and butter and the whole thing. But what do you say? Question did come up last night. What would you say if all of a sudden you're looking at your stack of pancakes, these rock layers, and you see one petrified tree cutting through all of those pancake layers? No deterioration. Now let's assume it was supposedly 100 million years of geologic history. No deterioration? And you say, no, that's not 100 million years. That all happened pretty quickly. Then you notice something else. The tree roots are totally broken off. What does that tell you? It was ripped up, replanted downstream. Okay, this had to be what's going on here. Otherwise, trees don't do well without roots. Okay, they weren't growing there. All right, now, what else would you do? It's not just one that you find, though. I've had people say, well, they just find a fossil like that. Maybe other ways. There was an earthquake. The tree fell down in a hole. No, it didn't work. Okay, that was at a university somebody brought up. And no, that did not work. Okay, so what do we see? That's one of those polystrate trees. Goes through many, many layers of our pancakes, okay? Well, you see a whole bunch of them here. There's one there. There's one over here. There's about 6 of them right in that picture. They're going through multiple layers. And it's not just petrified trees, other ones as well. Okay, now, here's one. It's same location. This one was actually photographed by National Geographic. Of course, they talked about over the millions of years how this, there's no way, no millions of years here. Okay, this has all happened very rapidly. Not only in the eastern United States, but you see them in Australia, Nova Scotia, Russia, Germany, all over, okay? And they're there. It fits with the catastrophic, flooding and quickly buried. Okay, now think about this one. This is the place I love to take students, called Catastrophe Basin in Utah, all right? And think about, what would you think if the bottom layer, that's supposed to be 30, 40, 50 million years old, somehow fluidized and poked up through all the other layers? Does that 50 million years make any sense then? No, it would have been solid rock, right? It would have been solid. You would not get that happening. But the diagram you see right there is actually right there from the Catastrophe Basin State Park. Okay, that's their diagram. And yeah, that bottom pancake must have fluidized. Okay, going up through various sandstone layers, including the Entrada, which is where you find a lot of the Arches National Park. Okay, it's not just one. There are 165 of these features at Catastrophe State Park. 165 of them. In the distance, you see one there in the upper left picture. You see it just poking out, just like all the way through. But its root was way down below it. All right. Here's one there next to my old man. That's an interesting one, poking up through there. Here's one, looks like toothpaste, squeezed out of a tube and then petrified. That's not a tree, by the way, okay? That is one of these sandstone pipes, we call them. Again, how do you do that over millions of years? what I say is there's something going on. The mud's being put down real quickly. Something catastrophically falls into it. Maybe it was an asteroid, big meteorite, and it goes into the mud. Anybody who knows hydraulics, when you put that much force into fresh mud, it's gonna pop up all over, right? From deep. That's what I think we're looking at, okay? It fits better with a catastrophic amount of flooding going on. And you can do some calculations. You can find out how fast the waters would have been, at least 150 miles per hour up to 1,000 feet deep or more, okay? That's gonna do a lot of carving, might even plane off what was the old mountains and give us what's now called the Great Unconformity, which is worldwide. It looks like something planed off. They'll say just millions of years of erosion. Well, maybe, but it's worldwide. But what's interesting is what's on top of this. This is that Colorado Springs area, okay? That's sandstone on top there. So you've got this Pikes Peak granite, the basement rock, with what they call there is Saguache sandstone, okay? It's a type, that's just the name of the type of sandstone. But it's interesting because that particular sandstone is found in other parts of the world, but it has different names to it. It's the same pancake as the Tate sandstone, which is on the top of the inner gorge of the canyon. The inner gorge. You got the big gorge, then you have the inner gorge. Tate sandstone is that one. You notice the size of the grains of sand in that sandstone. Some of them are blocks of rock the size of an automobile. You see that? That means high velocity, catastrophic erosion and deposition. Okay, now don't miss this picture right here. That sandstone, the same pancake, not only is at the Grand Canyon, but it is also on the top of Moran Peak in the Grand Tetons. And that's everything in white there is the Tate sandstone, the same pancake. All the way to the eastern seaboard, all the way north of Greenland even, okay? That is one big pancake, isn't it? You see, I'm looking at catastrophic processes that are continental wide here. What's going on here, okay? We have massive limestones as well, and different names, but the same limestone, okay? It's the same one. Manitou Springs, where you're at, they call them Manitou limestone. But the same pancake is at near Grand Junction called the Madison, okay? All right, but you go to Indiana, it's called the Indiana limestone. Same formation, same pancake. All right, so if it's the same pancake, that's another continental deposition here. The Niobrara Formation is a very important formation for the exploration of oil, okay? It's the marker. It's what you look for, and then you start drilling, okay? That's one of the keys here. But you find it at Glen Eyrie where it's standing on end. Why is it standing on end? Well, it was laid down flat like pancakes ought to be, all right? But what happened was Pikes Peak rose up, and when it did, it took the layers and put them up on end. You see that? So now at Glen Eyrie there in Colorado, right next to Colorado Springs, it's on end. You go underneath Colorado Springs and maybe a couple miles to the east, all of a sudden that pancake flattens out, goes all the way to the Atlantic Ocean. Okay? But it doesn't stop there. Okay? It doesn't. You find the same pancake across the ocean. It's called the White Cliffs of Dover. And the same pancake is in Israel, it's in Spain. They now think it's also in Australia. And if that's the case, we're looking at worldwide flooding and deposition here. Okay, so I'm going to say the most documented biblical event is supported by much archaeological evidence, and as well as that, geologic, archaeologic, all kinds of evidence, all over the world. So, is Noah flood fiction or reality? I say it's reality. All right, I would say that, yeah, that's reality. But there's an important thing about that. What we were looking at tonight was who's the hero of the plot. From what I was showing you, was it time? Doesn't appear like it. Was it water? A lot of it is water, isn't it? Catastrophe? Oh yeah. Water and catastrophes are the hero of the plot. And when you have that, you don't have to have that kind of time, do you? I showed you so many things that they thought would be millions of years old, but turns out, catastrophic processes. All right? Now, I didn't prove to you the flood, but it really does help substantiate that we can rely on that Bible, huh? It really does. And keep in mind, Genesis chapter 6 through 8 are some of the most contested books of the Bible. Did you know that? They're contested. The flood, you don't believe in the flood, do you? Yep, I sure do. Okay? And because of my scientific background, yeah, I do. But if those are correct, which I think my study is showing, then I better take the rest of the Bible seriously as well. And so when it talks about Jesus Christ coming, dying on a cross for our sins, I better not take that lightly, okay? Because the New Testament writers say, just like in the days of Noah, they're comparing what's going to happen in the future with what happened in the days of Noah, but it's going to be a different type of catastrophic event there, okay? Anyhow, I see evidence that we better take this Bible seriously and take the claims of Jesus Christ seriously too. So, thank you. Appreciate it. Thank you. And turn this back over to Parnell. He's the moderator. No, he's going to have questions tonight. Okay. So, right now, do you have any questions? Anything you want to talk about regarding this or something I've said the last, or Mary Jo has said the last 3 days? Yeah, go ahead.
So just to start out with, when did, using our calendar, current calendar, when do you think that the flood, Noah's flood?
When did it occur?
When did it take place?
Well, the only way we would be able to tell is look at all the genealogies as given in the Bible.
The question was, when do you think Noah's flood occurred? I'm just going to
When?
repeat that for
Thank
the
you.
recording.
We're recording it. When did Noah's flood occur? The only thing we can go on at that point, likely, would be the biblical record, where you have all the genealogies. You know how old Noah was. You know how old was it before the flood. We also find out how old he was when he died.
So then we would be kind of taking the assumption that the world is 7,000 years old and then working our way forward.
Actually, what I'm doing is taking the actual record. Yeah, I guess you would.
Okay.
Let's take the record, and we'll find out from Adam. We have all the genealogies. They really recorded those real nicely. He was so many years old when he had such and such a son. When that son was so and so, he had another one. You add up all those years, you're going to get 6,000 years, roughly, is what you're going to get. Maybe not quite that much, okay? But it's somewhere in that neighborhood. Now you place the flood at about 1,500 to 2,000 years. Then after the flood, you have Noah, we've got his sons, we've got all of the genealogies, and the Hebrew people basically did a wonderful job of recording all of those numbers, okay? And so, when was the flood? About 4,500 years ago, okay?
Okay.
That's a lot of time for a lot to happen, okay? A little bit of an aside here on that too. I had right here at the university, I had a student ask one time, how in the world did they have enough time from the time of the flood to the time of the crossing of the Red Sea, the Exodus? How do they get so many people? I said, okay, let's do a calculation, right? And actually, I'm a mathematician. I derived the equation to figure it out, okay? Then I found out, oh, I didn't need to do that. That's just a regular population rate of increase. Okay, that's all you have to do is plug in the numbers, and bam, there it is. Well, I ended up deriving the same equation, okay? And regardless of that, and what you do is rate of population increase is deaths versus births and all that. And I start with a reasonable number of people, and found out that few short years that the student said, from the time of the flood to the time of the Exodus, was about 847 or 57 years. Well, think about the population in the United States only in 300 years. Okay? You see how much it quickly expanded. Now, but you just take a very conservative figure for the population rate of increase.
They started with how many people though?
Let's start with 2.
Oh, okay.
Let's just start with 2. That's all you need to do. Noah and his wife. Okay? And we do a very, very conservative rate of growth. And it turns out, if you would say assume war, death, disease, famine, whatever, wipes out 50% of the whole world population every 70 years. What kind of population would you get after 4,500 years? It's interesting because the population number that I looked at and went, whoa! It's approximately what our present population was in this world. Okay? That's what it was. Then I thought, oh, wait a minute. What if I had 40,000 years? Isn't that what secular scientists are saying, that Neanderthal was around 40,000 years ago? They're having families, right? What would I do if there was 40,000 years? How many people would we have on the face of planet Earth? Enough people that they'd be standing on every square foot of planet Earth, on each other's shoulders, halfway from here to the distance of the next star. 40,000 years only. And all of a sudden, I looked at all these numbers, I calculated it, I recalculated it, I said, there's no way, I must have made a mistake. I didn't, okay? I thought I must have made a mistake. But what my conclusion was, deep evolutionary time is deep trouble for the evolution model. Okay? It doesn't work. That doesn't work. There's a question way back there. You want to give him a mic there so we can get it on tape? Tape. I bet you that was an old term, wasn't it?
I'm with you on
I
that.
look at this text. I look at this text in Genesis 8, and Noah built 20, verse 20. And Noah builded an altar unto the Lord, and took of every clean beast and of every clean fowl, and offered burnt offerings. Offerings on the altar. And the Lord smelled a sweet savor, and the Lord said in his heart, I will not again curse the ground any more for man's sake. For the imagination of man's heart is evil from his youth. Neither will I again smite any more every living thing as I have done. People leave this scripture out, but it seems like that initial curse of the ground that happened at the fall of mankind has been somewhat lifted from the earth. And people never mention this scripture that the Lord says, I will not again curse the ground anymore for man's sake. You know, and I bring it up because, you know, I mean, I guess it's not really always difficult to make a living these days, as bad as it was at the beginning, you know. But I just brought it up because nobody ever talks about this text. You know, people think that you know, you sweat of your brow, you have to eat bread and, you know, and work. So.
Well, we do, don't we?
Sure.
Okay, curse the ground.
It's Genesis chapter 8, verse 20 and 21
Okay,
and
all
22.
All right, have you looked, what version was that in?
It's King James version.
Okay,
King James version.
all right. 822, did you say?
Turned it on.
King James Version.
Let's see what it says in other ones as well. Mary Jo, do you have that in another translation? And do you want to add anything to what he was saying?
I think it's a good question for Parnell.
I was thinking that myself. I usually pass on the hard ones. Let's go with 8 and verse 22. I don't think it's going to show up there.
20, 21, and 22.
20, 21, and again, the ground me. I'll never curse again. ESV, NAS, okay. While the earth remains. All right, 21. Okay, well, as I have done might be the key verse there. As I have done. With what? A worldwide flood.
Yeah.
That's always the way I assumed it was he was referring to the event, the flood event, which was he'd never again flood the earth. That's what I thought.
Well, I see it as the additional curse from the fall of the ground as being lifted off. It's to some degree.
I think it's referring specifically to the flood because it's right at the end of the flood passage. Okay, that was the promise of the rainbow, etc. But keep in mind too, he says, while the earth remains, what do we have? Seed time and harvest.
Yeah.
Okay, cold and heat, and summer and winter, and day and night shall not cease. You know, and then God blessed Noah and his sons and said to them, be fruitful, multiply, and basically fill the earth. Okay, so it's and then he also gives them permission to eat meat at that point.
Yeah, right. Yeah.
And the cherubim would be on there, okay? And I think it's specifically wrapped up in destroy it as I have done. And I don't think that refers to the initial curse in Genesis chapter 1 at all. I think it's referring to the flood.
One thing to look at, just looking at the concordance, the Hebrew word there for cursed is different.
It's different
It
than
is.
the original curse.
Yeah, and I don't know
Is
enough
what?
it's a different word. So the Strong's word is, the Strong's word in Genesis 8, was it? Whatever you
Yeah,
referenced.
Genesis 8, yeah.
That one was kalal, it was like 7,000 something. The one in Genesis 3 is arar, and it's 779.
In
So it's-
concordance?
So it looks to be a completely different word. So something to kind of look into in the future. Like, are they related? I don't know from a brief search, but they seem to be.
Those are Strong's concordance.
Yeah, it seems that the numbers are different. It doesn't seem like it's related, but that's just a quick search.
Related to 2 Peter 3, yes.
So-
Okay, yeah. Well, Mary Jo's gonna, also has one other thing to say about that,
Okay.
because
You might want to also look at cross-referencing to 2 Peter chapter 3,
Yeah.
where Peter says there's going to be scoffers in the last days,
Yeah.
saying, where's Jesus? You know, basically, you said he's coming back, but he hadn't come back, and he's, You know, where is he? How come he hasn't come back yet?
Mhm.
And Peter takes his readers right back to creation and the flood, and he says that God isn't going to do that again, but the next time there will be a judgment, it will be by fire instead of the flood.
Yeah.
So, you know, it is still the principle. The principle is still that God is still in control.
Right, yes.
And that he has judged the earth in the past, he will judge it again in the future, and the only reason he hasn't done it yet is because he's patient, because he doesn't want anyone to perish.
Right.
Second Peter really brings it back to the character of God, his love, his patience, his desire for mankind to repent. So I don't know if that ties in with what you're
Well, yeah.
looking at.
I love to listen to recitation of scripture too. I think it's the old way of really hearing it. What stuck out to me today was the Lazarus and the rich man, and at the end it says Lazarus says, "I have 4 brothers, and if Lazarus you brought him back from the dead, they believe." And then Jesus says if they don't believe in Noah or they don't believe in the Old Testament stuff, the law of Moses and so forth, they won't believe even if someone rises from the dead.
What exactly?
Yeah.
Right.
So
Good point.
Yeah, it's that's even more scandalous than taking the curse off the earth.
We had a professor at another university who we talked about. A professor, what would it take for you to believe? He said, well, I suppose that if all of a sudden a cube of bronze would float down and appear right in front of me, and that cube of bronze sprouted wings, or turned into if cube of bronze would suddenly change into a giant squid, and then the giant squid will sprout wings and fly away, then I'd believe.
Okay.
That is. And then he mentioned something about the fact that, well, maybe he was hallucinating or something.
Sure.
So even if God did it right then, he says,
Yeah, then he
I'm
believed it was
going.
hallucinating.
I got a question. The fist into the layer cake. No. That was one question, but that's not my primary question. My primary question has to do with the water under North America. The example of
okay,
the mineral that sweats
the Dimwitty.
and it has enough water there. You said that was like equated to all the seas, all the oceans?
3 times the entire amount of water in the oceans just under North America.
So what's the depth of that? That sounds incredible. Like,
Well, doesn't it say when the flood, God opens the waters in the deep? And
the waters of the great deep, fountains of the great deep opened up.
He opens those
That
up.
could have been the release of pressure or something like that. It may have come through. It could have been water. Some people, we don't know for sure on that verse because we don't know the fountains of great deep, but that's all kinds of volcanic eruptions too.
Sure.
This is something we just don't know for a fact.
so do you get my question? Like the amount
It's a
of
lot of
water,
water.
the amount of water in the ocean seems so vast compared to how much could fit under North America. So how is there 3 times under North America the amount that's in the oceans? Do you understand? Like,
How thick is our crust of the earth?
yeah, I don't
It's
know.
like an eggshell compared to the upper mantle.
Okay.
It's an eggshell. I mean, when you look at that, how much water is in that boundary in the mantle?
Yeah.
That's where they're talking about, right there. And the reason they're seeing it is because of using seismic waves
Okay.
coming down and the reflections of it.
Yeah.
So is it
That's
your
how they're figuring
understanding that
it.
it's incredibly deep then?
It's very deep.
So it's much deeper than the oceans. It's just
Oh,
incredible.
yeah.
Okay.
Yeah. See, the oceans are sitting on top of,
Yeah.
you might say, the crust.
Got
Yeah,
it.
We have
they-
volcanic seafloor crust, we have continental crust,
Right.
and that's even below that.
Cool.
Okay? But even then, that crust isn't that thick compared to the rest of the Earth.
Right. I think I wanted to point out something. I've pointed this out in the past. I don't know if it was clear, but I did leave and go to the bathroom. But did everyone understand that Dave was talking about when he gave the example of the lakes, the inland lakes that were large, like multi-state sized, almost lakes, some of those, that when those, you would have potentially had dams that were holding those lakes in place, and then those dams broke way, theoretically, and gave rise to these amount of water just washing out, forming these canyons, such as the Grand Canyon formed by was it Bonneville? Was that the Grand
Bonneville,
Canyon?
Lake Bonneville, Lake Missoula.
And so that the guess is that those bodies of water were what were left after the receding of the waters in the Great Flood. So if there was a worldwide flood, then there's waters left that's captured in these inland lakes, probably many, but these are some examples. And then they just, they're temporarily held there by the conditions, but then the dams that held them there gave way, and then subsequent flooding events of smaller amounts of water leading to these giant canyons. That's the connection with the flood. It's just like, and I think too, the idea would probably be that when the flood left all these layers in the whole earth, soft layers, that this water that's breaking from these inland lakes that are remaining, when it's flooding out, it's washing through soft sedimentary layers. It's post-flood layers that have only been there for sure, who knows how long, but maybe weeks or months or a few years. I don't know how long, but
well, for instance, concrete, to totally cure concrete, depending on the mix, of course, 90 years. 90 years to do that. I don't know if you know that. It keeps getting stronger in a kind of a cycle here. Okay, it's about 90 years. And then, and so what you're talking about, it was not totally cured yet, which is a possibility. But we're not just talking, we've got the flood, which are going to put down those layers. It will start some canyons, I'm sure, as there's a sheet wash coming off of these mountains, as the mountains are coming up and the valleys are sinking down. But you also have, when you put up mountains, you're going to have natural barriers now for the flows of certain rivers draining off. And then those then will overtop their natural barrier. When they overtop, it's going to be catastrophic. Now, we also have conditions of the flood. Waters probably are very warm. Think about all of that volcanism that's going on underwater, okay? I mentioned that where the spreading was, that's all volcanism. We have volcanic deposits that were water deposited that cover 100,000 square miles, like the Deccan Plateau in India, the Columbia basalts, 30,000 square miles right there in North America too. And much of that is pillow, but means underwater, okay? But think about the heat that produces in the ocean. Doesn't boil it, but it adds a lot of heat to the ocean. It's at the heat in the ocean. Now that you got a warmer ocean after the flood too, you got the continents cooling down faster, but you still have all of those hot air masses coming across. That's just perfect for huge amounts of precipitation, even after the flood. Precipitation eventually turning into snow, turning into glacial ice. Now you have ice 10,000 feet thick over Minnesota, and 4,000 over Yellowstone, and further up in the Canada, it's even further, deeper. But when you look at that, now you have an ice age beginning, okay? Dr. Michael Ord, by the way, who's a meteorologist, did some calculations and all this kind of good stuff. And he has determined that you can get the total advance and retreat of glacial ice period, 500 years. 500 years, all it takes. And I understand that too. Okay? So, and that's where mammoths who are now repopulated, they're having a great time eating buttercups along the margins of the continent where it's still warm because we have all those warm ocean bodies, right? Then all of a sudden the wind switches off of, from there, off of the ice, and all of a sudden they're not only looking for they're looking for a down parkas, okay? They're really getting cold, and then the quick freezing of them as well later. Some of them are actually frozen in standing upright position, even in sand deposits. Okay? Go ahead. You're grabbing the mic.
Oh, thank you so much, David. Huh?
It'll catch him.
It's okay right here. Thank you, David and Mary Jo, for all three presentations. The first question I have is about, is it possible that before the great flood of Noah, that all the 7 continents were somehow more connected, and that therefore the pressure of that water is what broke up the continents? Because even one of your photos that showed, you know, North America, South America, and Africa, I've always looked at those and thought it almost seemed like they might have been connected at one point, and then the great flood would be the way that it did that because of the water pressure. I don't know.
It could have been that. I would not dispute that at all.
Water pressure, or is it volcanic and tectonic?
Yeah, it's a volcanic and tectonic and all that kind of pressure that I'd be looking at that probably is what I would look at. Now, yeah. Well, what happened to that other nice?
Did you have John Baumgartner?
I did, yeah. I snuck it in there while you were gone. All right, here we go. That's what, let me see, slideshow from current slide. It should pick it up right there, okay? But yeah, you notice that the Africa kind of fits in there. Every time we do it, there's a little bit of overlap anyhow. It's not good when you're working a puzzle to have pieces over the top of each other. But there are those kind of things that's going on. But also one thing I want to mention is on this particular model that I showed you, the runaway subduction model. All right, John Baumgartner's model actually predicted what the forces would be based upon the subduction with all this stuff coming underneath there. What are the forces? I can't remember how many force points he generated by computer in order to figure out what the forces would be. His calculations showed that basically when it would start breaking up as a result of this flood, when would these continents, and he starts with Pangea, okay? He does start with that Pangea, and his model actually predicts the cracking, etc., of those particular continents of Pangea. And it's all during that 1 year flood is when it started, okay? Now it's grinding to a halt. And so at one time it was going faster. And it's not just necessarily, it's widening at the rate your fingernail is growing. We're talking about really going fast for a while, but now slowing down. Okay? So that's what he is looking at, and I believe his model is a very good one. Anything
So
you want to add to that?
my second question is, I considered myself for some years theistic evolutionist.
Yeah.
I was still kind of not
I
aware
I
like
did myself
like
too.
you shared too, that you know you were theistic evolutionists, and now I've wakened up and become actually gone back to my roots as a young Earth creationist. Recently, I've been doing some reading where I don't understand it because I haven't done enough reading on it, but I've heard that there's people who, they're evangelical, spirit-filled Christians, but they refer to themselves as old Earth creationists. Do you have any comment or do you have any knowledge about what this is all about? Because it's so new to me. I mean, I feel if you're a creationist, you would think it would be logical to think of a young Earth, right? But now I hear of these old Earth creationists.
Good question.
Yeah.
Very good question.
Thanks.
A lot of times, what we believe about that position is, I think it comes about by looking more at the evolutionary scenarios, both for the Big Bang, the astronomy stuff, as well as looking at those rock layers and thinking in terms of radiometric dating and other things that people think were many, many long ages. And so then you have to kind of combine those age techniques, those age dating techniques with wanting to believe in the Bible. I think there's some real issues with the long age, calling it creationism. Personally, I think people have come from, a lot of times people come from an evolutionary long age view, and they, in our opinion, they quit too soon. They don't keep going. And I understand that because that's what we did too. We made a shift from evolution to creation, but it took us a lot longer to come to grips with, could this earth be, could it be young? And I think what they really miss is the impact of the flood. And I think that's one of the things that Dr. Henry Morris was way ahead of his time on. He was a hydrologist, and so he understood the movements of moving water and so on, the mechanics of that. And he focused a lot on the flood, and I think it's very important for us to understand the flood because the flood can explain those rock layers, which look like maybe they might have taken millions and millions of years, but it condenses the time into just one year. And and then the continental drift and the idea of the amount of erosion coming off of the earth and so on. So I feel like the flood is critical. It's so important, both theologically and geologically, if we're going to understand this earth. We like to take people to see the impact of even small floods. I mean, if you've been watching the news at all and you see the flooding in North Carolina and Tennessee, and the amount of mud, and that was now in our current experience that feels like a big flood, and it was with dramatic consequences. But if we could multiply that over the surface of the earth, how much erosion would it do? How much sediment would it carry? How much sediment would it lay down? And what would we have as the waters came off of the earth? There's a spot up just in Montana, just outside of Yellowstone National Park. It's called Quake Lake. And back in 1959, there was a major earthquakes up there in that area that resulted in a huge landslide. 1/3 of a mountain just slid down across a valley, up the other side. It blocked the river, and immediately those waters started to rise. And the geologists were going, "Whoa, we got a problem. We've got to get a channel for this water to come out, because if what was now a natural dam, if it broke through, it was going to cause tremendous damage downstream." But you can see, if you go to that spot, you can see how that mountain just slid like this down across the valley and way up the side. You can go right up there, you can see it. You come to camp next summer, Yellowstone.
Sure.
We'll take you there. And it's been amazing to us because we've had some kids even that said that was the most dramatic part of the whole Yellowstone trip to them, was looking at Earthquake Lake and the damage that was done by that one earthquake. Well, actually, three quakes along 3 different fault lines all at once, though. That was back in 1959. You can still see the damage there. And so, again, geologically, that's a small event in a localized place. But if you multiply that, and you would have had, I think we think of the flood, or I did. I think a lot of people think of the flood. They learn about it in Sunday school, and the rains came down 40 days and the water came up, and that was the extent of the flood. And what they forgot to teach us in Sunday school was, wait a minute, that flood water was on the earth for a year. Noah and his family were on that ark more than a year. And so it took 5 months for the water really to get to the top level. And then the rest of the time it was coming off and it was draining. Personally, I think this earth is still drying out from the time of the flood.
And said the waters were washing to and fro over the earth. That's gonna do a lot.
So I think we really need to come to grips with that flood, and theologically and geologically, as well as what it did to create a biological bottleneck. So many species of animals that were wiped out at the time of the flood. Now God brought 2 of every kind, which we think was more like 2 of every family of animals onto the ark. But there were a lot of species that got wiped out. And so I think the flood had a whole lot more impact than what we usually think about it.
I think you're gonna find out that virtually everybody that does hold to an old earth creation model will also not hold to the biblical record of the flood.
They take a local flood.
They'll call local floods that had, catastrophic effect, but not global. All right, Dr. Ross being one of them, Dr. Hugh Ross, who was one of the started really pushing on that old earth. There were other Davis Young, there's several others who were pushing on that old earth. But they were all, none of them that I know of would have accepted a global flood of the type that the Bible was talking about. I like what Ken Ham says, this flood is like taking a basketball and pushing it down into a swimming pool. Okay? That's the kind of flood we're talking about. Okay? Okay. Other thoughts? Go ahead.
What are the greatest challenges you're facing? I don't understand why more current day geologists don't accept these findings. Is one of the greatest challenges that they're not looking close enough at the flood? Or what is the greatest challenge to get current day geologists to believe some of these things?
Repeat the question.
Does that question make sense?
Go ahead and repeat it.
Don't say
Should
it
we
again.
hear, let's give you the mic.
What's the?
You have it.
Charles.
Oh, okay. What are his basically what he asks? Go ahead. He'll ask.
Yeah, I'm just wondering what are the challenges in getting current day geologists to believe some of the findings that you've developed and brought together.
To get him to come out to a program like this tonight.
Okay, just getting them to listen.
Right.
That's right.
That's a lot of it, but a lot of it is the worldview that they've been inculcated with throughout their whole education and been taught that the earth is old. And so you have to interpret your geology in terms of millions and millions and millions of years then. And in order to change, you have to have a way to be ready to change your paradigm.
Right.
And a lot of people aren't willing to do that.
Right.
It is a big step, and especially if you've been in academia for too long and your job might be on the line if you change it. And, or it has implications based on based on your worldview of whether you're willing to accept a supernatural interpretation versus a naturalistic interpretation. Because, so many times it comes down to what is your worldview. And a lot of times it comes back to people wanting to say, well, that's a Bible, and that's a religious book, and it's an ancient book of myths, and we can't talk about that in the science classroom. And so I think there's a lot of barriers that way.
Right, it does seem like much of what you're talking about, though, still can fit into a naturalistic worldview. I mean, you're showing how this happened.
Mhm.
Not to say that God didn't start it,
Right.
and, it wasn't because of his doings, and it's not diminishing him, in my opinion, but that's why it just seems like a lot of this, you're explaining how it happened,
Yeah.
and yet people are still not even willing to even listen.
Catastrophic processes can work within a naturalistic worldview. I agree, but not to the extent, and not what we are seeing today. You might say catastrophic processes are okay. Flood is not. Not according to the naturalists, because that was something God caused, the worldwide flood. So it's ruled out. And so they might look at catastrophic. Huh?
The subduction model.
The
subduction model does
That
show it.
should be perfectly okay
Right.
to bring into a classroom, shouldn't it?
If they would at least open their minds to listening to that. Okay.
There's the key. I was speaking at, again, Colorado School of Mines. I had a professor there that I got a chance to talk to, and he was really interested in what I was saying. But then he did say, when we were having lunch together, he said, if I buy into what you're saying, and he admitted that it's looks pretty good, he said, then I'm going to have to rewrite everything I've written in the last 25 years. I just said, are you willing to do that? He said, I'll have to give that considerable thought. Okay?
That was a good answer.
Good answer.
That was a better answer from him than to say, oh, yeah, I would, or no, I wouldn't, to say, I'll have to think about that, and count the cost. I mean, it's like coming to Jesus. He says, count the cost of discipleship. Same kind of an idea. But it's so hard to change a worldview. It is just amazing how hard that is when you've been taught that, and when you think that all of the science fields point towards evolution. If you have to go back and start reevaluating everything you've been taught, it can take time. Now, people do that, and we know a lot of scientists who were trained as evolutionists in biology or in geology or other fields, and they have changed their mind. They've come around. But it does take a process of really intellectual, you have to be open to
Humility.
it. Honesty, humility, yeah.
I listened to some creation scientists on a talk show, late night talk show. They said that there's a possibility that creatures that are like 6 inches long and maybe 2 inches wide, and all the other creatures that are much smaller, bacteria and insects, and that they could develop such a degree of traits that they would speciate. But I don't think they were talking about evolution necessarily, but that they would speciate, or they would create, new variations of themselves. And I also heard someone say that, like the fact that viruses can mutate and create new forms of themselves that are resistant
Right.
to pharmaceuticals, as well as the fact that when we didn't use pesticides and herbicides, a third of the crops were eaten by pests. And then when we started using pesticides and herbicides, the amount of crops that were eaten by pests was still a third, is now still a third. So it's very interesting that there's some giving away to some kind of evolutionary thought. But do you agree with these creation scientists or not?
Yeah, I think it's the way you look at things, whether or not from a strictly naturalistic evolutionary point of view, they start with no life, and you get really what they call primitive forms of life, which really we don't believe there's any such thing as a primitive form of life.
Here, I'll do it.
Well, just back up a foot, because right now you're under the speakers. You're standing up and you're under the speakers.
So
There's a line of speakers right there. You're standing up right under.
So-
You're right underneath.
So like Parnell put up on the board there, we kind of think that what God created, he said the kinds, reproduce after your own kind. Where are those levels? There are creation scientists who are doing the research, trying to work backwards to figure out what those levels were. I think personally that in some of the groupings of animals, it's more at the family level. It seems like in plants, a lot of them may be more at the genus level. But what we're seeing is a diversification within that level. And so you start with genetic material rather than building up lots of genetic material. So from an evolutionary point of view, you have to generate all this new genetic material, where from a creationist point of view, those basic types were created during creation week, and you see diversification from that, like we showed with the Punnett square on Wednesday night, I guess it was. And so
Get all the skin colors.
yeah, it's just like you're going two different directions, And so we can, yes, speciation to me is not evolution. When you start dividing things out, each of those species has less genetic variability than the genus level or the family level. So I think God created things with a tremendous amount of genetic variability potential, and that's how we have the ability for animals especially, and plants too, to adapt to some extent.
That is smaller.
Chihuahuas and St. Bernards.
Yeah, well, yeah, Dave was just bringing up the idea of dogs, Chihuahuas and St. Bernards.
Yeah.
Now they will still, you can still mate those two together,
Yes.
but in the wild it's pretty tough,
Yeah.
They're not gonna mate in the wild very easily, and mankind has been able to develop all these various breeds of dogs within the last 200-300 years primarily, and we do it by selective breeding, but we might breed it for what? The color of the coat, or the size of something, or and oftentimes in doing that, we bring it to a point where it couldn't even survive in the wild anymore. Because we bred out the genetic variability. So the most stable population is a diverse population.
Yeah.
So yeah, I think what you were saying, I think I agree with what you were saying there.
And another thing about antibiotic resistant bacteria, about YAP or DDT resistant insects, basically when they kill them off, the new insect breed isn't as strong as probably the original one.
Right. Yeah.
Because now you've killed off this whole segment of your genetic area, and what's left is weaker. Okay? It's weaker in general. Okay? Thanks for that great question.
I like
You had a
the,
question too?
I got a comment real quick. I like the example you guys give. When we're talking about subduction, we're talking about the mountains rising up, and the spreading of the seafloors. that we observe today, that they uniformitarianists and evolutionists believe happened at that rate for long periods of time. I like the example you guys give of a skier going down the hill, and imagine if you could capture a video of that skier, but only the last moment. So the skier is going down the hill, and all of a sudden, comes to a stop, and that last second of stopping would be very slow, right? You just catch that last moment of the stop. And if you were to only have that moment when it came to a stop, and if you were trying to say, how long did it take that skier to come down the hill? You only have that moment, but that's your moment, that's your time frame, and you're saying the skier was moving so slow. And that last moment, it must have took 1,000,000 years to go down that hill, But you're only capturing that last moment of time. So when we're looking at the current processes of the spreading of the plates, of the C4, whatever, you're looking at just our picture now, but we don't know at the rate that it happened in the past. I like that example.
Okay.
Question? Was there a question?
Thank you.
Thanks for coming.
And I think you had a question, you still have a question?
Yeah, I think I can still
Just
formulate.
So we had talked about this maybe the first day we talked, but in evolution, typical evolutionists believe in a common ancestry. And I'm wondering, again, I'm trying to see how we can bring sides closer. And if evolutionists would believe, and there are some that do believe this, in multiple lineages and not a common ancestry, to the point where maybe it could be hundreds, let's just say. Is there a spot in there when you would accept that is truly creationism? There would be a heavenly Father, a God, a universal intelligence that started this all, but it started, rather than coming from one common ancestry point, which most evolutionists believe they're struggling to try to make that happen. It came from, let's just say, hundreds of lineages, each one being slightly different, but all coming from the same materials, and God had a way of figuring this out. Was that?
Sounds like a lot like creation now.
Yeah, I know. But I'm saying it still ties into evolution, but it's less down to one point. It's is there a way to bring the sides together so that one side is more willing to look at the other side, and I don't know. I'm trying to figure out a way to get it to a kumbaya moment.
Yeah. It's more like, according to the standard evolutionary model, they look for the tree of life, right? Where they all come from a common ancestor way back in time. And otherwise you have to postulate multiple times that life evolved on the earth, where the creation model says we're going to start with we might call it a forest instead of trees. And maybe the dog kind is one of those trees in that forest. And maybe the cat kind is another one of those trees. And so you have a diversification taking place within that family perhaps, or that category.
Or even species.
Or even within a species. But usually it's probably a little, when we look at species, or this thing is all artificial. The classification scheme is based on human reasoning. The Bible talks about the kinds, and so for people who want to study that, the creationists who are studying that, they have coined a term they call baraminology. Bara meaning created, kind, and so bara meaning kind. And so the created kind, the study of the created kinds, trying to work backwards to figure out what were those original created kinds.
Are there charts of that?
People are doing some research on it. but that's a huge job. But we think that most of them would fall somewhere along these lower levels.
I'm thinking even if you can get to the family level
Yeah, Yeah.
and then get some common agreement
Right.
as to how those develop.
but the question is, where do you get those family level things? Did
Right.
they all come about by accident and chance, or were they created in the beginning? And from that, we get diversification. So it's almost like, are we working from the bottom up, or are we working from one of those levels down to
Right.
more and more specifics? And yes, theoretically,
I'm trying to bring macro evolution and micro evolution together a little bit.
yeah,
So
and
that,
I'm not sure if you can do that. Because I think when you get to macroevolution, you now are talking about everything coming into existence
Yeah.
by chance and accidents. Where we come at it from a different direction, say, no, it was supernaturally created, and what we see now is the diversification of these kinds. Where, according to evolution, we gotta go the other direction.
so just to
Now,
be-
if we were only just looking at the genetics in this level, and we didn't try to make it into a grand scheme of things, I think we'd be a whole lot closer.
So just to clarify where you're at, I'll just try to speak louder.
It will get captured. If you can hear him, it'll be captured.
Yeah, just to get a clarification of where evolutionists are, creationists are at. You would say it started at the family level, and what we have today, God started with the family level of, again, it's.
We don't know,
Genus.
we don't know exactly what those created kinds are. That's what the research is attempting to do, is to say, where were those original created kinds? What were they? Was it, some things I think were family level, sometimes some things were genus level, some might have been species level. But that's a huge, it's a huge
It could be a
research.
range there, yeah, okay.
Yeah.
Yeah.
But I mean, I don't know that we could say everything was at the family level.
No, you're right, because some things are still around today
Yeah,
that were around when God created Earth.
right,
And-
Yep.
And,
yeah.
okay, so.
And I mean, what he showed last night was a lot of there are so many things that have not changed much
Exactly.
over what they say are millions and
Okay.
millions. They call those things the living fossils.
Which I would not believe in those millions of years anyhow. I call them evolutionary years. They
Okay.
need the time, I don't.
Okay,
Okay? Understand that?
okay.
I think for me, the main difference is, where do you get the variety of, how do you get the genetics for the varieties that we have on the earth today? If you start from an evolutionary presumption that life evolved and everything came from a common ancestor, it stretches the imagination to think that you could get all of that genetic variability by accidents and chance. The creation model says, no, you start with a level of complexity, and you're going the opposite direction instead.
Okay.
So it's like if you could take a bucket of marbles, okay, representing all the genetics within the dog type, okay, and you reach in and you get a certain handful, well, maybe that represents Chihuahuas.
They're not different species either.
No, a different mixture might represent Saint Bernards,
Sure.
Some might represent wolves or other kinds of dog type creatures.
Okay.
Okay, I think, yes.
I think you've said before, it sounds like you're kind of trying to understand why maybe there's lots of people with, there's biology, you guys have all this evidence and all these problems with the current model. Why aren't there other people joining? And I think you've said part of it is that the biologists are told, oh, the paleontologists all agree it's going to be millions of years. These are the fossils. The radiometric dating people are millions of years. And they all see the problems in their specific genre, or they can be told about the problems, but they're told that it's certain science on all these other fronts. So that's kind of what I've heard you say
That's
before.
true, yeah, that's what happens. Oftentimes, if somebody's researching in a particular area, they might start wondering, how does that fit with the evolutionary model? But then they think, the geologists think the biologists have the answers, and the, you know, and vice versa.
I think, I'm sorry, are you continuing?
Go ahead.
Go ahead.
I was not gonna comment on your train of thought, I was gonna go back to something else, so if you were continuing to talk, I'll just wait.
No,
I
go
think
ahead.
we're okay.
I think, I don't know if you guys commented on this while I was writing up there, but I think one of the differences between the evolution camp and the like macroevolution camp and the creationist camp is the assumption of what causes the diversification. I think that I think we would both probably agree that natural selection is part of it. And all the mechanisms that are involved in natural selection, whatever that be, like separation of groups, bottleneck effects, die-offs, you know, and obviously the pressures of environment, and but what is causing the genetic drift or whatever, or what, you know, I think our assumption, you guys correct me if you're wrong, but our assumption is that most of the change is not mutation. It's not mutation driven. Most of the change, I think, in our thinking is,
Intelligent design.
I mean, it's just built in, and it's
Yeah.
pressures. It's like, it's some combination between what's built into the genes and the pressures on the earth of the different environments.
Sure.
Versus mutation driven, like in the evolution model, it's assumed that it's like it's entirely mutation driven. You know, it's all this deletion and addition and subtraction and scrambling of genes, and I don't know. You guys, you want to comment, Mary Jo?
Yeah, well, I would agree with you there. To complicate it even further is when you start adding epigenetics into it, because then now all of a sudden we not only have the DNA that we're talking about with mutations and so on, but we're talking about factors that are attached to the DNA which can control which set of genes are turned on and which ones are turned off. And, you know, to me that adds a huge level of complexity. But I'm excited about epigenetics for another reason, is because the genetics itself, just the DNA structure, it explains a lot, but what it didn't ever explain sufficiently in my way of thinking was, well, how does that interact with the environment? And epigenetics has a way of explaining how do we have the same DNA structure, and yet we have a mechanism by which animals, let's say animals and plants, can adapt to varying environments. And I think in the years ahead, I think epigenetics is gonna become more and more important in understanding the adaptation to environments and how do living things adjust to differing conditions and so on.
And here's a question for you that's fascinating.
Is it right along that same line? Okay, go ahead.
Predictively,
Predictively what?
if people are going to stick with the evolutionary assumptions that there's no God involved, it has to be a naturalism, has to be lots of time. It's materialistic assumption. How do they now take the what we learn from epigenetics and continue to rule out short time periods, supernatural, and just say it's only long time periods and no supernatural? How do they use epigenetics looking forward now? And you could, down the road here, 10 years or so, you can say, I predicted this 10 years ago in a lecture when Parnell asked. How do you think they're going to take epigenetics, what we learned, and still force it into the assumption there's no God, and it took lots of time.
That's
I think in the long run, that the naturalistic assumptions are gonna be getting less and less. And you see it now with people who talk about an intelligent universe. And somehow, yep, the universe itself is an intelligence. They call it the cosmic consciousness or whatever. Or you hear people praying to the universe.
Yeah.
And
New Age.
and New Age kind of stuff that tries to put characteristics that are associated with intelligence and consciousness, and to impose that upon molecules.
Yeah.
And I think that's the direction we're going, because you're seeing less and less people that accept exactly a totally naturalistic, and I think the reason for that,
Ultimately, I suppose the assumption is the DNA itself is the intelligence.
well, DNA itself or
The universe.
the universe they're saying is
but not God.
but not God. And I think then we end up coming back to, we had a question the first night, I believe it was, well, how do you know which God then is the real God? And I think that question comes back to, well, the first issue in this creation evolution debate is what we see the result of intelligence or just accidents and chance? But then if you say it's intelligence, then you've got the next question is, well, what or who is that intelligence? And you come back then to the character and nature of God, or can just molecules have that kind of intelligence? And you really end up being back in a matter of faith. I mean, no matter how hard you try to escape it, you always come back to a matter of faith. And it's a matter of where do you place your faith? And I believe, we believe that the Bible is the best record of the existence of God, and reveals his character and points us to Jesus, who is the perfect representation of God.
I think Jesus is a key modern quote unquote example of a historic figure with eyewitness accounts that are strong, saying, okay, you gotta deal with Jesus.
Exactly.
Right.
He this person, right?
And what this other gentleman talked about before he left was, even if someone would come back from the dead, if they do not believe in Moses and the prophets and what they wrote, they wouldn't believe if someone came back from the dead, which is exactly what we have with Jesus. We have ample evidence that he rose from the dead, and yet people will reject it. And so, again, it comes to a matter of what are you willing to accept and believe, and where do we submit, and where's our humility in all of that, and where's the wisdom of man and the wisdom of God? You come back to those fundamental religious questions. The whole evolution creation debate really is on the level of more the secular naturalistic kind of thing. But then you come into the question of the character and nature of God, which is where it really gets exciting.
One of the things that I should point out too, there are major problems from what I had talked about on the first night. Not only Mary Jo talked about some of the major proofs for evolution that really fail, okay, the epic fail, but also so many design features that the naturalists have to explain only from a naturalistic viewpoint without God, okay? And I'd say, like, for instance, how do you get the cell with all the highways, with the molecular machines, etc.? You're not going to explain that naturally, okay? It's got to be all there at the same time. You might say, oh, we might be able to get this or this from this. and that's what they'll teach you in a biology class. But it doesn't really make sense when you look at that whole picture, everything taken together. And even if somebody has put together, like I used to, evolution and creation together, as a theistic evolutionist way back when I wasn't even thinking about the issues at all, there are things that you have to come to grips with. You know, design is one of the biggest ones. And every time you look at a different feature, okay, where did the eye come from? One cell was sensitive to light someplace. Now it's on its way to becoming an eye. It's like a human eye, right? Yeah, right. That's a few steps missing in there, okay? But all of this stuff, even when you look into specific species, there's an idea that perhaps some of those species themselves were created. Like, for instance, I want to mention this one right here. And I think it's going to show up here. Yep, it did. There's an article came out in 2016. It was talking about orphan genes. Now, what orphan genes are genes that a specific, you might say, species has, or might even be a subspecies has, that have no evolutionary ancestors whatsoever, even within that species. Okay? It's almost like, boom, there it is. Like in apes here, in their 634 of those particular, quote, orphan genes that have no evolutionary ancestor in humans. They're there. There's one tree in that forest, okay, and what you were talking about. But the apes, again, the chimps, there are 780 in chimps that humans don't have, and vice versa, right? And within the ape kind, it's the same thing between all these different apes. There are bunches of these things called orphan genes that can't explain why do you have it without any precursors in its supposed ancestry, anywhere on the line. And not only there, but it's also honeybees, okay? Honeybees has a whole bunch more, and there's an article that basically said the gene honeybee orphan gene sting evolution. That's the name of the article. Jeffrey Thompson, Dr. Thompson, and basically is saying the same thing with the genes of bees, and even within different species of these bees, or even within different colonies and types of the bees, there's a whole complete set of genes. Where do they come from? Okay, so that to me says that evolution doesn't work frequently, even on some of those narrower levels of like species or subspecies even.
Do the orphan genes have any known function?
Oh yeah,
They do.
they have they're functional.
It's just they don't know where they
But
come
all of a sudden there's no evolutionary ancestry to show where it comes from, even from an evolutionary, especially, perspective. And that shoots evolution a big hole right there.
I
Right
really
there.
think that,
When you see it on the species level even, okay?
I really think that we're gonna, the more that we understand about genetics and biochemistry and the workings of the cell, I think the more we learn, the more we understand about it. That complexity that we see is layer upon layer upon layer upon layer of complexity. And we tend to think, oh, well, our sciences, we're zeroing in on the end point. Probably not. Because probably we're just digging a little deeper and finding more and more levels of complexity. I wanted just to read you a scripture from Hebrews chapter 11 that I find very fascinating, because it says in verse 3, it says, by faith we understand that the worlds were prepared by the word of God, so that what is seen was not made out of things which are visible. But the part that's very interesting there is, by faith we understand. And in our modern society, we think we got to understand first and then we can have faith.
Yeah.
And the Bible's saying just the opposite. By faith, it opens up our understanding.
Wow.
And so, you know, it talks in Corinthians about the foolishness of man's wisdom and that God's wisdom is so much higher than man's. And so I think that, again, he says without faith it's impossible to please God. And so God values faith.
Yes.
He values faith, you know, and trusting in him. But just consider that scripture, by faith we understand. Not the opposite, not by understanding we have faith, but by faith it opens up our understanding.
Very good point. Yeah. All
We can
right.
probably close it out and then just hang out if you guys
Oh,
want
I'm
to
glad to
continue.
hang out and discuss things.
So, yeah, Dave and Mary Jo, thanks so much. We really appreciate that.
You're welcome.
Thanks, everybody. Yeah, so encouraging, the material, so we
Thank you
appreciate.
for all your work putting
your
this
ministry.
together. I'm sorry that your signs are getting stolen by people who somehow are so open-minded that they want nobody to know these presentations
That's right.
are going on.
That's right.
Yeah, so
Maybe just
both
one person
nights.
too.
Yeah,
Did they survive tonight?
they did. I saw one person looking at them and they fit the description from the video, but
Yeah.
I was watching them, so they knew they were watched, so they left. So the signs are fine, you know.
Thank you very much.
Thanks, guys.
Thank you too. Again, give me your name.
My name is Jerry.
Jerry,
Jerry.
last name.
Oh, Meissner, German name.
Meis-
Meissner.
Meins-
Meisner.
Meissner. Meissner.
Yeah,
Okay, good.
M-E-I, German spelling.
All right, no problem.
Mary Jo